Okay, so let me continue the discussion. We were right here. So this is a addition product. Okay, so let me do this. This is the addition product. Where are we? This is the addition product. This is the shorthand notation for this. The addition product. So this addition product breaks up like this. So this is 1, 2, 3, breaks up to give you a triose, two molecules of triose, and the name of this molecule is the name of this triose, let me write it down here. It's the name of this triose. The name of this triose, okay, let me add another carbon. The name of this triose is glyceraldehyde. Sorry, phosphoglycerate. It's called 3-phosphoglycerate. This is also called as also called as 3-phosphoglyceric acid. Okay, so this is produced from this addition product right there, this triose, and this triose is actually 3-phosphoglyceric acid. This is what you get. So let me write down the structure of this 3-phosphoglyceric acid. So you know that this is basically glyceraldehyde, right? This is glyceraldehyde. This is D-glyceraldehyde. If I want to convert into glyceric acid, I convert this CHO into COOH, it's a carboxylic acid group, right there, and CHOH. And this is actually 3-phosphoglycerate, okay? 3-phosphoglyceric acid. So it's basically, this H is replaced by H2PO3. That's a phosphate group. So it's going to be phosphate. So this is 3-phosphoglyceric acid. Alright, so this is the structure of 3-phosphoglyceric acid. Okay, so this is one of the intermediate. This is called 3-PGA. 3-PGA. Okay, it's called 3. There's another name for this. So what happens next is that this 3-PGA. Okay, let me write it down right here. 3-PGA. This, in the presence of an enzyme. The name of the enzyme is phosphoglycerate kinase. Phosphoglycerate kinase. In the presence of this enzyme, this 3-PGA gets converted into 1,3-biphosphoglycerate. And how do you do that? This reaction is just introducing a phosphate group. So what we do is we introduce a phosphate group here. You understand that? If we introduce a phosphate group, if we replace this H, by H2PO3. Now how do we do that? This is done in the presence of phosphoglycerate, and you react it with ATP, adenosine triphosphate, and the products are 1,3-biphosphoglycerate or 1,3-biphosphoglyceric acid plus adenosine diphosphate. So this guy loses one of the phosphate to form ADP. So this is the step. Okay, this is what happens. Alright, so let me write down the structure of this particular compound. So 1,3-biphosphoglycerate, nothing, you have to replace this by let me it's H2P, right, H2PO3. So this is 1,3 by 1, 2, 3, 4, right. 1, 2, 3, 4, right. So 1,3-biphosphoglycerate, 1,3-biphosphoglyceric acid. So this is what forms, and later what happens is that this, in the presence of another enzyme, the enzyme is glyceraldehyde 3, sorry, I got spelling wrong, glyceraldehyde 3-phosphate dehydrogenase. We will talk about this. Glyceraldehyde 3-phosphate dehydrogenase. This is an enzyme, and this enzyme basically catalyzes the reduction with NADPH. And this forms glyceraldehyde. Phosphate. So let me tell you how this happens. All right. Okay, let me explain this step. This step is very basic, very important. All right. This step, we took 1,3-biphosphoglycerate. This is one of the intermediates, and one of the intermediate compounds formed. This intermediate compound is formed by this method. We take the 3-phosphoglyceric acid, we react it with in the presence of phosphoglycerate kinase enzyme in the presence of ATP to form diphospho derivative. So and that gets converted, ADP gets converted to ADP. This is what we get. This is 3-phosphoglyceric acid. Alright, and after this, we've took this 1,3-biphosphoglycerate and we reacted it with the presence of glyceraldehyde 3-phosphate dehydrogenase. This is one of the enzyme which catalyzes the reduction with NADPH, which is formed in the light reaction. This is actually formed in the light reaction. Okay, so this guy is formed in light reaction, NADPH, and what we do is basically we reduce this entire thing into a carboxylic. This is a carboxylic acid group, right? If you actually place H, this is carboxylic acid. But now this is a phosphate ester. Okay, we reduce this phosphate ester. We reduce it in the presence of NADPH and enzyme dehydrogenase, glyceraldehyde 3-phosphate dehydrogenase. We reduce this to form glyceraldehyde. So we're reducing it basically to aldehyde. Okay, that's what happens. We're reducing a phosphate ester to aldehyde. So the structure of this 3-glyceraldehyde 3-phosphate looks like this. The only difference is that this group, this entire phosphate ester linkage, has been broken down to this particular, it has been reduced. So this doesn't change. It's H2 here, double bond O right there, and O, P, double bond O, OH, OH. So this is called G3P, glyceraldehyde 3-phosphate, one of the most important compounds. Let me write it down again. G3P, glyceraldehyde 3-phosphate, one of the most important and most useful intermediate or the products formed in this carbon fixation. Okay. So let me show you what we've did. So just take a look at what we basically did. Okay. So this part of the entire part we did, this part is called phase 2. So phase 1 is carbon fixation, where we introduced oxygen, where we introduced the carbon dioxide, and we have broken down successfully RUBP, ribulose 1,5-biphosphate, into glycerol and into this compound, phosphoglyceric acid. So this is the step 1, the end of the step 1, carbon fixation. This is what we did. We formed this particular intermediate. Then we took this and we converted it into a biphosphate compound, and then we reduced this biphosphate ester to form this particular compound, G3P. This is an aldehyde. So this is a reduction reaction. This is the second part and part 2 of the Calvin cycle, phase 2, also called as the reduction phase. So next phase is going to be a very crude phase. The name of that phase is actually called regeneration of RUBP, where we actually regenerate ribulose biphosphate again.